Hey guys, welcome back to another video. In this one we are solving a time period problem from SHM using force method. So let's get started. In this problem we are given with a complex situation where there is a disc and there is a rod on the disc. The rod is attached with a spring and again the spring is attached to wall. It is given that there is no slipping between the disc and rod and the disc and ground as well. Now the rod is displaced a little bit in horizontal and released. In that case, what is the time period of oscillation of this system? So pay attention here. If we displace the rod by a large value, then the spring will be compressed by a large value and the spring will push the rod by a force kx which will be large. In that case, if the applied force is too much, which is more than the maximum possible friction between these two, in that case the friction will go into the kinetic nature, means the rod will try to move with different velocity and the disc will try to move with different velocity. In that case the friction will be in kinetic nature, which will make us lose some energy, right? So that's why this part is important, that the rod is displaced a little bit in horizontal. So now let's solve the problem. So here if we displace it a little bit, the spring gets compressed. So let's say we displace it by an amount x. That means the spring gets compressed by an amount x. In compressed state, this spring will try to push the rod and that force the spring will apply will be kx. I think at this time, if the acceleration, if we talk about the acceleration of the system, think what are the forces acting on the rod now? If for now, just time being, let's assume there is no friction. Let's say there is no friction. So this kx, it will try to move the rod towards left, correct? It will try to move the rod towards left. And if there is no friction, then the rod will move towards left, but the disc will not move at all, because on the disc there will be no force. So in that case, the possible relative velocity of the rod is towards left with respect to the disc. The rod is moving towards left, so the relative velocity of the rod with respect to disc is towards left. So if we look at the contact point, we know that friction opposes the relative velocity, right? So if the relative velocity of the rod is towards left, then friction on the rod must be towards right. So on the rod we have two forces. There is a friction here. When we have displaced it to the right and released, there is a friction on the rod and there is kx value here. So two forces are there on the rod. So if we write the force equation, we can write it this way: Fr minus kx equals to ma. So net force Fr this way, kx backward. So Fr minus kx is the net m into a of the rod. Here now, to get the time period, we need the equation in this format, right? A equals to minus of omega square into x. We need it in this format. But see, we have a friction which is not helping us here. There is a friction extra. So we need to substitute the friction value with something else, right? So we need the relation between friction and acceleration or something. Friction is a force. So let's try to write friction in terms of acceleration. How can we do it? See, the friction here is also acting on the disc and disc has mass m. In this case, think for pure rolling. In case of pure rolling, about this point, we can assume this point is the instantaneous center of rotation. We can assume the entire disc is rotating about the bottommost point. This is the ICOR, instantaneous center of rotation, right? So about this point we can assume the whole disc is moving. Now as the system has acceleration a, that means this point has acceleration a. Now this disk is a rigid body. If we write the torque equation for the disk, we will write it like this. About the bottommost point, we are writing the torque here. Why the bottommost point? Why not center? Because there might be friction here. So if we want to write the torque equation about center, then there will be two forces coming into account, one force here, one force here, and this will be an unknown which we do not want to mess with right now. We don't want to increase the number of unknowns in our question, right? So I am writing the torque about the lowest point. So this force into this distance, it will be the torque. So our friction into 2r, the distance here is 2r. The net torque equals to I alpha. Now we know that in a rigid body, the alpha of any point with respect to any random point. In the rigid body, the alpha of one point with respect to other point is always same. In a rigid body, that is the property of rigid body. So if we can write the alpha in terms of A, then we get the value of friction and A, the relation between friction and A. So this I alpha, we are writing the moment of inertia I about the lowest position, the lowest point on the disk, and the moment of inertia about this point will be ICOM, that will be ICOM plus md square by parallel axis theorem. For the disk, ICOM equals to mr square by 2, and md square, d is the distance that the axis has shifted, right? So here the axis has shifted by r distance, so mr square. So we are getting the moment of inertia as half mr square plus mr square, which is 3 mr square. Now the alpha value, how to substitute the alpha value in terms of A. Now here this point is moving with acceleration A, and because of pure rolling, this point has acceleration 0, and the distance between them is 2r. So alpha we can write A relative by the distance between the 2 points, which is A minus 0 by 2r, or alpha equals to A by 2r. So this value if we put here, so instead of alpha we are using the value A by 2r. So we are getting Fr into 2r equals to I alpha, and that I alpha sums up to this value 3 by 2 mr square into A by 2r. This gives us Fr equals to 3 by 8 small m into A. Now we got friction in terms of acceleration. Let's substitute this value in this equation. So instead of friction, we are getting 3 by 8 small m into A minus kx equals to capital M into A. We just substituted the value of friction here. Now rearranging the equation, we get minus kx equals to m plus 3 by 8 into m into A. So A equals, we get A equals to minus of 8k by 8 capital M plus 3 small m into x. And when we write this, we get the form A equals to minus of omega square x. We got this form, right? So here this value right here, this gives us omega square. So we get omega square right here, which is 8k by 8 capital M plus 3 small m. Now time period is 2 pi root over of 8 into capital M plus 3 into small m by 8k. This is our answer.